So this example, we're looking at a second order differential equation. We need to solve this to find the general solution, and then we need to find the solution given a couple of conditions. We've got a condition on the derivative and also a condition when x equals 0 and y is equal to negative 1/8. So the first part of this is part A. So what I'm going to do is write down my differential equation, and that's equal to cos squared x. Let's rewrite my d, that looks funny. Okay, so you can see that we've got something which is a little bit difficult to work with, which is cos squared x. So it's a good idea to use one of your substitutions. And if we have a look at our formula sheet, you can see here we've got cos squared x is involved in two places. Up here with the sine squared x, that introduces a sine squared x though, which we probably don't want. And here with the double angle formula. So if I go back now, just pop that there, you can see that the option that's probably good to go with is the one here that introduces a double angle with the cos. So we're just going to use cos of 2x equals 2 cos squared x minus 1, which implies that cos squared x equals cos of 2x plus 1 all over 2. So that's what we're going to use. So we now have our equation, second order differential equation, which is now, instead of this, we're going to use this. So it's a half cos 2x plus a half. We're now going to integrate both sides. And when we do that, we're going to end up with dy dx on the left side equals a half the integral of cos 2x and the integral of a half. So we're going to have dy dx equals a half. The integral of cos is sine 2x, and we then have to divide by 2. A half becomes the coefficient of x, plus we introduce a constant c1. So we have dy dx, just simplifying, is sine of 2x on 4 plus x on 2 plus c1. So again, we want to find the general solution, so we're going to integrate both sides. And so we get y on the left side, and we integrate the right side. We're integrating all of this with respect to x. So we get y equals, integral of sine is negative cos 2x. It's already over 4, but we also have to divide by the 2. Plus x squared, it's already over 2, but we also have to divide by the new power 2. c1 becomes a power of a coefficient of x, and we end up with another constant c2. So therefore, we can simplify this. We get y equals 4 times 2 is 8, so we get negative 1/8 of cos 2x plus x squared over 4 plus c1x plus c2, and that is the general solution because we've got the two constants still in place in our equation. I'm just going to put a bit of a box around that one because that's our big result there. So we've got our general solution, that's the first part done. The next part says what is the particular, and it should really say here particular solution given these conditions. So let's take our solution here, put that on the next page. And let's also take our conditions and put those on the next page too. Okay, so for part B, we know that when x equals 0, we've got dy dx equals 0 when x equals 0, and when x equals 0, y equals negative 1/8. So we've basically got these two conditions. And x equals 0, y dash equals 0. So let's use the first condition. Oops, this one. So I'm going to put x equals 0 in everywhere and y equals negative 1/8. So that means we've got negative 1 over 8 equals negative 1 over 8 cos of 0 plus 0 plus 0 plus c2. And the cos of 0 is 1. Okay, so that's going to become 1. So we have negative 1/8 equals negative 1/8 plus c2, and that implies that c2 has to be 0. So that gives us this constant. The next condition we've got involves the derivative. So what we'll do is differentiate this equation. So we get y dash equals, differentiate both sides, negative cos, sine, negative cos. That's going to turn into positive sine. And that's all going to be times 2. Or if you want to, we'll take the 2 out the front, because the derivative of the bracket goes out the front. And then we'll have plus 2x over 4 plus c1. That's the derivative. So simplified, it's a quarter sine 2x plus x on 2 plus c1. Okay, now we've got our condition, so let's substitute that one in. I'll do this in a different colour. Let's do it in green. So I'm going to put when y dash equals 0, x is equal to 0. So we have sine of 0 plus c1. We know sine of 0 is 0. So this means, that's kind of boring, 0 is equal to c1. So both of your constants in this equation, which is a little bit boring, actually end up being 0. Okay, so that means that we've now got our two constants solved for, this one and this one. We know they're both 0, which means they'll both disappear. So we can finalise our solution now, which means that our particular solution, is y equals negative 1/8 of cos 2x plus x squared over 4. And because we found that the two constants were equal to 0, they don't turn up in our solution anymore. So this example is really all about doing your your integration twice to find the solution for y, the general solution, and then identify the conditions that you have to find the constants. Two unknown constants means that you need two conditions, and that's why we have the two conditions here. And it's very often that they give you one condition in y and one condition in the derivative, because it then requires you to differentiate what you've found and work with that as well.